Hello, Ben.
Hello, John. Good to hear you
What a surprise to find you here.
Not really a surprise because the Rust release train is right on schedule.
And I guess also because we planned it, I suppose.
We did plan it. That is true. Not surprised because we didn't just bump into that right here.
Yeah, I know, right?
Yeah.
How do you feel about being halfway to 100 releases?
Wow, it's really it's quite a milestone. I personally am halfway to 100. Excellent.
The real question, I guess, is what happens when we tick over to 100? Does that mean that the 1 point gets incremented to 2 point?
I suppose.
That's scary stuff. Scary stuff. The real question is, does Rust 2 come before Rust 100?
I mean, what do you think? Let's make right now. Let's make a bet and see if history will venerate our decision.
I think there's a really strong desire to never release Rust 2. Because I think it's just going to cause a lot of pain.
In that case, then let's take a bet on at which version Rust will begin doing the Java thing and just totally omit the 1 point before every single release number.
Oh, yeah, that's a good one. I think that's going to happen with release 100.
100, maybe. That'd be a good milestone for it.
Yeah, I like that.
All right, that's our prediction.
All right.
I mean, what is it? 6 more years, we'll find out if it's true.
And this podcast will be around to give you the message.
We'll be here. Write it down.
All right. So today we're doing Rust 150 and Rust 151 as has become tradition now. And that actually works really well because 150 is sort of the end of the era before Const Generics, and 151 is the start of the era after. And clearly this is going to be a land shift moment, right, Ben?
Well, it's been rolling in for a while. I think we have had a few things from the previous releases that have been showing the harbingers of Const Generics. Now,
and that's
really
why I'm pretty happy why we're doing both of these at the same time, because I feel like 150 is sort of cleaning up all the stuff inside the inside the standard library that makes use of Const Generics, and then 151 is sort of, now we're ready to let it loose on the world, at least in some limited fashion.
I wouldn't quite say all the stuff. There are still some things that aren't quite perfect, as we'll get into today.
That's true, but that just gives us the opportunity to make things even better in the future.
Right, there's no challenges, just opportunities.
Exactly. So the first thing in 150 is const generic array indexing. So this one struck me as a little weird because I've always been like, can't you always just index into arrays? Like, wasn't that always a thing? But I think what's really changed here is now arrays implement the index trait for any length array.
Like, officially they do. Previously it was magic, right?
Yeah, exactly. And I think the magic didn't implement the trait. Like, you were able to use like square brackets to index, but the index trait wasn't implemented for arrays of arbitrary lengths.
So we can remove some edge cases from the compiler where it's like, yeah, square brackets should defer to index unless it's an array, in which case use this like magic over here.
Yeah, and I feel like it's also nice for library authors, right? Like now, if you're generic over index, you can actually take things that are arrays without having to force the user to make a slice first.
Oh, that's pretty cool. I didn't think about that use case. Yeah, that's nice.
I mean, I don't know how many use cases are generic over index. The best example I can think of is imagine that you have a data type that's like generic over its backing storage.
Yes.
And it implements index if its backing storage implements index. Then that will now work with arrays.
Yeah.
The next thing that in 150, I guess, is const value repetition for arrays.
So this isn't actually, this is not, in fact, a brand new stabilization. This is just sort of an oopsie.
Yeah, which is so funny.
World.
Do you want to talk about the oopsie a little?
Yeah, sure. So in the array repetition syntax, maybe you've seen it before, it is square bracket, some expression, semicolon, and then some number, like, 5, 10, whatever, closing square bracket, and that gives you an array of that length filled with that value. Previously, sort of, in this release, it is acknowledged that you are now allowed to use a const as the value here. Specifically, not for the length, which has always been true, but for the expression itself. And so, but in fact, this has been true for, what is it? Rust 1.38. This actually became true. It was accidentally kind of released into the wild. And in this case, it's not like really a bad thing that it was, but it wasn't entirely intentional. Just one of those things that kind of like went under the radar. And so now this is acknowledged as being stable.
Yeah, it like accidentally worked.
Yes. So it's official. It actually is here. And you can rely on it without feeling bad now.
I think one thing that made me really excited for this is that you might go like, well, why are constants interesting here? But with all the work that's been happening on the constification that we've been talking about over the past, year or so?
Years.
Is really cool because now you can do things like you can create an array of vec news because vec new is a const method now. Or imagine you have some super like complex data structure. You can now store a const none because none is a const. Well, I guess maybe none you could always do that with. No, it had to implement clone or copy actually. But now you could have some really complex type that does not implement copy. But if you have an option of it, you can still create an array of them by setting them to none because none is a const expression.
Mm-hmm. Yeah, it's a lot of, I think arrays are the big beneficiaries of the Const Generic support landing now, where they're kind of like, they're going from sort of magical language-provided things to more like library type almost. Still a primitive, still fundamental, and privileged too with their own syntax, but way less of their own like special little snowflake sort of data structure.
Yeah, it's really nice. The next one is kind of interesting because this ties back to I think what we talked about in 149, so in the previous episode, yeah.
Certainly, yeah.
Which was in 149, what just to sort of recap was it suddenly it enabled you to implement drop for unions, and it allowed union fields to not just have to be copy, but they could also be manually dropped. And the idea here is that when you drop a union, you don't know which variant the union is. That's sort of the point of a union. It might be one of many different things. So you can't actually drop any of the fields. And any type that implements copy does not implement drop. So that's why a union could implement drop and contain copy types. And what changed in 149 was that it was also allowed to implement drop if it contained manually drop types, because they don't get dropped. They are manually dropped. And what was realized in 150 was that because they are manually dropped, it should be safe to assign to them as well. Right? So imagine that you have a union, you don't really know which variant you have of the union. It's always safe to just assign to a given field of any of the variants of the union if it's manually dropped. Because the act of writing to the union is safe, right? Because reading from a union is unsafe anyway. And the value you overwrite gets dropped, but it implements manually drop, so it doesn't get dropped. And so the change here is that now it is safe to assign to a manually drop union field. Whereas previously
it was a surprise.
It was like only safe to assign to copy fields before.
Because my mental model of unions is like, well, they're the unsafe version of enums, and so like everything's unsafe in my mind for a union. But actually, it makes sense. Like they're like sort of like how making a raw pointer in Rust isn't unsafe. Although we'll get to that in a sec. But reading it is. In this way, sort of writing to a union is totally fine in this case, but reading from it isn't.
Yeah.
So Rust is pretty precise about this to not have to have too much unsafe lying around where it's not needed.
And I do really like this sort of endeavor to find, let's make all the things that are safe be safe.
Mm-hmm.
Another thing that I thought was, like, it seems like a sort of a small change, but it gets us a really cool optimization that I don't think we've talked about on the podcast before. And this is the idea that on Unix platforms, file now has a niche. Niche?
I say niche. I'm not sure. I'm not an Englishandarian, so
I think it's niche, because a niche, if something is niche, it's weird. Well, maybe, I don't know.
This is kind of niche.
Yeah. I don't know. Well, I guess a niche is like something that's highly specialized and narrow. So maybe that is what it is.
So yeah, let's talk about that real quick. So a niche for file on Unix platforms. And so we were just talking about unions and how a union is the unsafe version of an enum, and they're unsafe because the compiler or also the runtime code itself can't actually check what variant of your quote unquote enum you are in right now. You have to keep that track of that manually, and programmers are distracted sometimes. Sometimes they're tired, have had their coffee, so they can get it wrong. And that's the idea of enums can do it safely, unions can do it unsafely, and enums do it safely very often, most of the time, or in a not sort of a naive sense, by not just having thing A and thing B that are in the enum, the data that you actually want to track, but also having another field, a secret hidden field that tracks which variant of the enum is currently active. And is this exists in the enum. But Rust, being a language all about zero-cost abstractions, wants to try really hard to not impose this extra memory cost on users. And so, what if we can kind of squirrel away the enum variant data somewhere inside the data that's being held in the enum already? And so, the obvious example of this is, imagine a reference. Your enum contains a reference somewhere. References in Rust can't ever be null. They can't ever have the value 0.0000000. So let's just say that, but it's not invalid for it to exist like that on, say, the file system or in memory. And so if Rust wanted to, it could put some data there. And in this case,
in this case, like a single bit of data.
Yeah, all you need is you have a single bit of data, which doesn't sound like a lot, but actually that's enough to completely eliminate a byte's worth or more of data from an option being the classic enum, where it's either a thing or it's not, because in the not case, that only takes a single bit of data to describe. So if you have an option where the sum contains a reference to anything, that option, the size of it, will only be the size of a single reference and not the size of two, in fact, because you would actually, because of alignment and padding, or I guess it's just padding in this case, you would need to have double the size, right?
Yeah. And I think it's interesting because it doesn't have to be just option. And I think this is something that's been worked on internally sort of in Rust C, which is to find a way to, and this might have landed already on Nightly, that the niche optimization is actually supported for, I think it's any enum where one variant does not hold data and there are only two variants.
I think it's been unstable for a long, long time. It's not just Nightly. I think this has been around for like years now that users have been able to take advantage of this.
Yeah, but I think what's in Nightly now is if the niche is larger and there are more variants and all of them hold no data except for the primary one, then you can take advantage of that too.
Okay, yeah, it gets smarter all the time, so it's a pretty involved thing. I think it's smart enough to even have, like, say, if you have nested options, it might be able to contain the data for both variants inside of the niches.
Yeah, depending on the size of the niche, right?
Yeah.
And I guess to bring this back to the changelog, what has changed in 150 is that a file on a Unix platform is represented as what's known as a file descriptor, which is really just a number, but it is specifically a signed number, and it's a number that cannot be -1, because -1 is used on Unix to represent that an operation failed, and then you need to go check the error codes. And so -1 is a niche for file on Unix platforms because it just a file cannot ever hold that value as its file descriptor. And so it can be used to represent none for an option file instead.
Yeah, squeezing out memory savings. That's a great use of Rust time, I think.
That's true.
And those are all for the language features. We have some library stuff, unless you want to talk more about that.
No. I think the library changes in 150 are pretty interesting. The first one is like such an innocuous looking method. So this is the then method on bool, and the then method is pretty straightforward. If you have a bool, there's now a method on bool called then that you pass in a closure, and then it returns an option of the result of the closure. So the idea is that if the boolean is false, then will not call the closure and return none. if the bool is true, then will return some of the value of calling the closure. So this is sort of a cheap, hacky way to turn a Boolean into an option. But the amount of work that it has taken to stabilize this method is just ridiculous. Mara, who's one of the, I think, standard library maintainers. So Mara commented on Twitter that this took 2 years of discussions, more than 10 proposed renames, several hundred GitHub comments with over 10,000 words in total, 4 proposed final commenting periods, and several video calls for this to actually land in its current format.
It's bike shedding of the highest order. It's so small and trivial that means that everyone has to get a word in.
Yeah, and it's interesting, right? Because people had a lot of opinions here. There were everything from this should never be stabilized because you can do it so simply already. It's not worth having a special method for. There was the argument that maybe we should just implement like into option unit for bool, and then people can just use into combined with like option map. Maybe it should be called and then instead of then. It's just there were so many proposals, so many suggestions, and ultimately, I think you're right that it's mostly bike shedding. But I feel like it's nice to have something that landed that's just like short and sweet. And I know for me, like this will come in handy in certain like one-liners that can be tidied up. The other thing that landed in 150 is the clamp method on ORD and on floating point numbers. And the two are sort of related. Like the reason it could be added to ORD was, I think, because it was added to F32 and F64. That might not be true. Oh, it's a good question.
No. They don't implement ORD, no. Only partial ORD.
Yeah, you're right. You're right. I think the implementation of clamp for ORD is really interesting, though. So clamp, for those of you who don't know, it's a method that you give it a lower bound and an upper bound, and it returns the input value, but sort of saturated to those bounds. So if the input value is lower than the lower bound, it returns the lower bound instead. If the value is higher than the upper bound, it returns the upper bound instead. And this is not hard to implement yourself using min and max, but it is sort of weird. Like you have to pass the lower bound to max and the upper bound to min to get the right value. And it sort of twists your brain. And so clamp is just a much nicer way to do it. And there's been a clamp method on the integer types for a while, but now that it's on ORD, if you have your own types that implement ORD, you can now use clamp directly yourself, which is really nice.
Yes, and clamp is defined on ORD, but the floating point types do not implement ORD, but there are now just inherent versions of these on those types, so you can still use clamp.
I wonder what happens if you clamp an F32 by not a number.
Well, it talks about this. So if it's, let's see, the value returns, let's see, this function returns nan if the initial value was nan as well. I'm not sure what happens if you give it a nan in the clamp value because you can't obviously check at compile time.
Yeah.
We could try that out.
Nice.
Clamp it to a nan. Oof.
What happens if the upper and lower bound are both nans? Which nan do you get back?
Yeah, what is the sign of the nan that you get back if they're both nans, but they're different signs?
Yeah.
Just nightmare of floating point.
The other stabilizations, I think they're not too exciting. There's OR insert with key on btree and hashmap entries. So if you haven't used OR insert with, it's a really cool, if you haven't used entry, you should definitely look up the entry API. It's fantastic. But if you have used it, you might have used the OR insert with method, which is if you have an entry into a hash map or a btree map, OR insert with is if this entry doesn't hold a value yet, then insert the value you get from calling this closure. And OR insert with key makes it so that that closure is supplied with the key for the entry that's about to be inserted. This is like a nice quality of life improvement.
I think that's it for the new APIs.
Yeah, and then of course there's the traditional set of constifications. None that struck me as particularly odd this time, except maybe pow. So this is the exponent function for integer types. So now that can be computed at compilation time. I did also take my usual deep dive into the detailed release notes. I found two that were pretty interesting. The first is that the compare and swap atomic method has now been deprecated. And this is something I think that it was decided a long time ago, like back in Rust 112 or something, that this is probably something we wanted to do, but it hasn't actually landed now until 150. And the idea behind deprecating compare and swap is that atomic operations are already pretty hard to understand and make your way through. And the standard library already has the compare exchange method, which is strictly more powerful than compare and swap, to the point that compare and swap, I think the compare and swap function is implemented by calling compare exchange. And so the idea was we should surface as few atomic operations as we can get away with, and then just document those really well. And that's what's happened here, that compare and swap is now deprecated and they recommend compare exchange instead. If you're curious about the difference between these, it really gets into like atomic memory orderings, which are their own kind of special weird sauce. But basically, compare exchange is the same as compare and swap, except that you can specify different memory orderings for if the swap succeeded or failed. And this is important in certain like lock-free algorithms and also just algorithms that end up calling compare exchange in a particularly hot loop or on a hot path, where you can do something useful if the exchange fails. In that case, you don't want the compiler to sort of, or the CPU to sort of stall out because of a forced memory ordering if the exchange failed. There's a lot more detail there that I don't think it's worth getting into here. But basically, compare exchange is a more powerful version of compare and swap. So we should just have that be the one that's in the standard library. The other thing I found in the detailed release notes is that Cargo now has reproducible crate builds. And before you get too excited, this does not mean that Cargo builds are reproducible. That's still something I think that's being sort of investigated, but that's a much, much larger task. Instead, this is if you run Cargo package, which is what happens when you run Cargo publish as well. Cargo package will take all of your source files and your Cargo toml manifest and stuff, and basically create a source tarball for your project. And that's what ends up getting uploaded to crates.io. So if you run a Cargo build, when all your dependencies are downloaded, it's those .crate files, which are really source tarballs, that get downloaded from crates.io and then extracted, and then that's what Cargo builds. And now the process of constructing those tarballs is reproducible. So if Ben and I have checked out the same commit of the same sort of repository, and we both run Cargo package, or Cargo publish for that matter, we end up producing and potentially uploading the exact same tarball. Like they would hash to the same value. This normally doesn't matter too much, but it is really handy when you have larger build systems and stuff where you want to make sure that you only recompile if you know that something is actually changed, which means that if something hasn't changed and you run the same procedure, you don't want it to create like a new file that seems like something has changed.
I imagine it could also be useful just for security to like know that you have like read the repo for a crate, and then to actually ensure that the repo contains the code, or the crate contains the code in the repo.
Yeah, that's also true.
Package it yourself and compare the hash.
Yep, absolutely. And this is something you could imagine like doing. You could like check out a bunch of just random crates and then do a Cargo package and then check that the hash matches what's in crates.io to see that no funky business has happened.
Yeah.
And I think that's all I had for 150. I feel like 150 was like a sort of small release. Like all of the stuff there is good, but it's fairly small stuff. And that's okay. Like I feel like all of it is good sort of forward progress.
That's the train model for you. Sometimes, there's not many passengers in the train. Sometimes there are.
Would you say that there are many passengers on the train for
There's at
151?
least one really big passenger on this train. Rust 1.51, the newest release of Rust. The headline feature of this one, we've been kind of teasing for quite a long time now, is the Const Generics MVP. And you do gotta stress the MVP part. This is not the fully realized, the final form of Const Generics as it will exist someday. This is just the kind of most minimally useful subset that kind of works right now and is solid enough to stabilize. So in this case, all of the goodies we've been talking about for the past few releases now, where a standard library is now implementing, say, index for arrays and doing all kind of stuff. Now you, the user, can do that yourself in your own code. It's all available to you right now, and I've seen plenty of folks very thrilled to be able to make some of this in their own crates. And so, if as a Rust library user, I'm sure within the next few months you will start seeing your own dependencies update to make use of this in various cases. So, do you want to talk more about the Const Generics support here, John?
Yeah, I think one thing we're going to see is a lot of projects deleting like macros that they've written to implement a trait for arrays of various lengths. Right? Like people have a
That
macro
feels
that
good. Yeah.
like there's so many of those like that just implement the trait for all different array lengths up to 32, 64, 100 or whatnot. And all those can now go away, and suddenly arrays of longer lengths will be much more usable in the language. And this also means that arrays are more useful for things like if you want to store, say, like an image file that has fixed size, like known resolution size. You can now actually store that as like a contiguous array with a known type, rather than having it always be dynamically typed or dynamically sized. And that's just really nice. It just feels more proper. It feels like you're encoding more information in the type system.
That said, there are still some libraries I've seen that have not been able to fully replace their either macro or type system shenanigans with Const Generics because there are a few restrictions still.
Yeah, so I mean the restrictions are they're a little bit they're definitely for more constrained or not constrained but more involved use cases. So one is you currently can only use uh, I think it's bools, characters, and integer types. You can only be
Yes.
const generic over those kinds of types. Um, and I think sort of in the ultimate version, right, you'll be able to be generic over any constant value of any type or of any particular type you give. That's not currently something you can do. Um, you also currently can't have the constant generic have a value that depends on other generic parameters. So you can't say that like I'm generic over some const m and this other type is going to be generic over m plus 1, for example. Um, like you can't put in expressions that are themselves generic.
And I think
Uh,
expressions in general are kind of limited right now. You can't have like a where clause for Const Generics that are like, where, x equals m plus n or anything.
Yeah, exactly. And it also can't depend on like other generic types. So if you have if you have some type that's generic over T, you can't use const generic inside of there and then pass in like mem size of T. Like that's also not supported yet. So there are some limitations, but they're ones that I think are expected to be lifted over time. And it was more like the current set that we have enables so many things that weren't possible before. So we should get that out the door because it's just like super valuable in and of itself. And then over time, we can relax the restrictions that are in place.
Yeah, there's a great blog post on the Rust Insider blog that we can link to. Well, let's assume that we have linked to it, and you can click it below.
That future selves have already have had added links to.
That one future self is now remembering to link, and that future listeners are now remembering to actually click on.
Nice. Um, The other thing that's really cool, I think, and that's sort of related to this const genericification, is that now we finally have a way to take an array and turn it into an owned iterator. With a slight caveat, but do you want to talk a little bit about this?
Yeah, sure. So, just briefly, for loops in Rust, pretty cool. You can kind of like, if you have, say, a vector, you can just say for thing in vector and then curly brace, and it gives you an array. And that is a pretty nice little piece of syntax that any user type can opt into, not just the standard types, by implementing the IntoIter trait. Actually, specifically the iter : IntoIter trait. And so if you do this, then whenever you use this type in a for loop, it will implicitly behind the scenes call IntoIter on that type and then iterate over that value that it gives you. So there's now that we can possibly implement IntoIter for arrays, like I remember how we just talked about implementing index for arrays, it should be possible to do it. And it is possible to do it, but there is a bit of a problem. So in Rust, there is a thing called autoref. And so if you have a method, for example, let's say you have a method and it takes, there are receiver types. There's self, ampersand, mute, self in these methods. How do you call these? And so if you have an ampersand self method and you have a value foo, you don't need to say, parenthesis, ampersand foo, parenthesis, dot, whatever. You can just say foo dot whatever. And then Rust will, behind the scenes, generate a reference for you to that type. This has some complications with the resolution, though, with how arrays and slices interact. So slices have always been usable in iterators. You can always be able to say for x in some slice, curly bracket, and that operates via the IntoIter transformation. But the thing is, so slices are always reference types. And so even if you take a slice by value, the elements inside are going to be by reference. And so in this case, if you had an array and you tried to call .IntoIter on it, what it's going to do is it's going to say, hey, I don't see IntoIter on this, but I do see that if I reference this, I will get the IntoIter implementation on slices. And so that is today what happens if you have an array and you call .IntoIter on it. Now, it's not...
or just pass it to a for loop, right?
Yeah, any of this. Well, actually, no. So today, if you pass it to a for loop, it's like, if you have a for item in some array, nothing happens. That doesn't work. Does it? I don't think it does.
I thought that worked, but let me...
I think it's specifically the problem is about calling .IntoIter on an array, an actual array. And the thing is, because it's going to reference your array and then turn it into an iterator, you're only going to be able to get the elements by reference. And so it's actually no better than if you had called array.iter, because iter is the trait, or iter is the method that gives you a by reference iterator naturally, where IntoIter is by value, iter is by reference.
And you are completely right that it doesn't work if you do like for item in and then you give it an array.
Yeah, it wants you to add on the ampersand there to turn it into a slice first. So the idea is we could add the implementation of IntoIter for arrays, but now suddenly that would break code that because it changes the actual value internally of what you get back from the iterator. So that's going to be, previously it was going to be a reference, now it's just the raw value, the owned value. So for at least over maybe a year and a half now, this problem has been foreseen, even though Const Generics hasn't been stable or even usable for that long. And so the idea is Rust has been warning for quite a while now that if you have an array and you call .IntoIter, you get this warning that says, hey, in the future, this might change, just so you know. This is an example of a future compatibility warning that could change at some point. And Rust uses these occasionally, often at addition boundaries, to change behavior in ways that otherwise might break some code. And so there have been various Crater runs, and Crater is the tool that gets used to check to see if any of the code on Chris.io would actually break from doing this. And there have been some regressions and from the theoretical doing this. And so patches have been sent, but many of these projects are older and obviously aren't being maintained anymore, kind of just like languishing out there. And so the idea is, well, is there a way of doing this over the addition for implementing IntoIter for arrays? Is there a way of maybe just breaking it or a way of mitigating it somehow? And so the compromise that exists right now is to say, hey, let's not worry about implementing this trait, but let's still provide a way to get an array by value, not have to make it into a slice first and only get the elements by reference. And you could do it via the cloned method on iterators to get a cloned copy of the values inside the iterator, but we don't want to have to introduce unnecessary copies. This is Rust. So there is now a new struct in the array module. It's called IntoIter, kind of confusingly, but the idea being this is hopefully temporary, transitive sort of thing. And so the idea is you import array : IntoIter, and then you can call IntoIter : new with an array that gives you an array by value with no extra copies, no fuss. And so in the future, this might become redundant or maybe someday even deprecated in favor, hopefully, of having an actual IntoIter implementation on arrays. But in the meantime, there's no reason that arrays can't take part in the fun of being turned into by value iterators.
I was really hoping that maybe it would be possible to have IntoIter implement from array, and they could just do for item in array.into. But unfortunately, the type inference is too complicated. But yeah, I wonder. It sounds like maybe this will happen on an addition boundary.
Yeah, there are some complications to be determined. I think right now there's been another creator run queued up to see if the so one of the things, the problems, kind of like getting into the behind the scenes here, is that a lot of people wouldn't have noticed the warning because it might have been happening inside of their dependencies. And when with cargo, when you compile, a warning into dependency isn't necessarily shown. And so the idea here is that with these future compatibility warnings, they will bypass cargo's hiding automatically of any sort of warning, and it will actually show it to the user. And I believe that recently landed in cargo, so it's not stable yet, as far as I know. And so once that does land, then we definitely should be more confident that people will have seen this in their dependencies and will have either, fixed it, forked the dependencies, transitioned to new ones somehow. But that might not happen in time for the edition, and it's unclear if an edition could have two different iterator traits to control whether or not you're doing this or that. So it's up in the air still. We'll see what happens.
It's an exciting future prospect.
It's always exciting with Rust.
Speaking of cargo, actually, cargo got a pretty major new feature in this 151 release too, and that is cargo got an entirely new feature resolver. And that might not mean much to you if you haven't been digging around in cargo's internals, but basically one of cargo's primary jobs is to resolve all your dependencies. So that is, given the dependencies that you specify in your cargo.toml and all of the versions that are available on crates.io, which versions of which crates do I have to compile in which order with which features? It's just solving that problem turns out to be very, very, very hard, but cargo does a pretty good job at it. And one of the sort of, let's call it simplifying assumptions that cargo made in the past, and arguably for good reason, was that if you have two paths to one dependency, so imagine that you depend on bar and you depend on baz, and both bar and baz depend on foo. So you have think of it as a diamond shape. And then imagine that foo has two different features, feature A and feature B. And bar enables A and baz enables B. Then cargo will sort of unify these features. So cargo tries pretty hard to avoid compiling anything twice if it can avoid it. So rather than compiling foo once with A and once with B, cargo will just compile foo with A and B both enabled. And in general, that is the behavior you want, because you don't want to sort of compile things lots of extra times and then have lots of sort of duplicated but not quite duplicated artifacts sitting around. But the downside of this unification is that cargo sometimes goes a little too far. So one example of this would be, imagine that bar is uh, a dev dependency and baz is a non-dev dependency. Then you don't really want to merge the features across them, because if you're doing a release build and you're not planning to do a debug build, or you're not planning to do a test build, you just want to build the release, you don't really then want to compile through with the features that are only used on testing. The best example of this might be, imagine that you pull in something like Tokyo, right? So Tokyo has a lot of different features. Some of them are very small. Like if you have Tokyo with no features, it compiles basically nothing. It's just like a bunch of traits and maybe a couple of types. But there are some features that bring in a lot of stuff. Like if you enable like the multi-threaded executor feature, that's a lot of code that has to be compiled. Most projects will only include the sort of multi-threaded runtime feature in their tests, in their dev dependencies, because they need them for tests, but not in their normal dependencies. But the way the cargo used to work, it would always compile Tokyo with all of those features, even if they were only used for testing and you were doing a release build. And that is, of course, unfortunate. It means that you spend a lot more time compiling than you otherwise would. And there are cases where this even breaks builds. And this is part of the reason why it was decided that a change had to be made. And that was, imagine that you're doing cross compilation. So let's say that I'm on Linux and I want to compile for Windows. Then now imagine that in my build dependencies, which are run on Linux, I enable the Linux feature of foo. And in my dependencies, so what gets built for Windows when I do a cross compilation, I enable like the Windows feature. In the old resolver, cargo would then go, oh, so I'm going to unify and help you out and compile foo with both the Linux and Windows features. But the Windows features don't compile on Linux and the Linux features don't compile on Windows. So I end up just being unable to compile foo when doing this kind of cross compilation. And so this is a problem. There are some other examples around hosts and proc macros and stuff that we don't need to get into. But basically, you can see how this becomes a problem if you end up over unifying in a sense. So what happened was that the fantastic cargo maintainers decided to implement a new version of the resolver that had this behavior that it understands when it needs to keep features separate and when it can't unify them. So for example, you can't unify across targets, across host types, and you probably shouldn't unify across dev dependencies unless you are doing a test build. And that landed with this additional field you can set in cargo toml that says resolver equals 2. When you set that, you're telling cargo to use this new updated smarted resolver. Unfortunately, the sort of second generation resolver can't be the default because it's not backwards compatible. There might be some crates out there that have a feature enabled in their dev dependencies that are actually needed to build the crate, even if you're not building the tests. But that wouldn't be visible with the original resolver because it just unifies them for you. So if it might be that if we landed resolver 2 as the default, crates wouldn't build because they would end up with too few features enabled when doing a normal build. So for now, it's a specific thing you have to opt into when you create a new package. But I think the plan is based on the RFC that this new resolver is going to be the default in the next edition. It's a pretty cool change. Like I'm very glad this lands. I think it's going to make a lot of compilations be faster because you end up not compiling more than you need unless you need it. It also has some implications, I think, for things like no stud crates, where you might want to like compile it with stud support when it's a build dependency, but without stud support when it's a real dependency. Really, this like second generation resolver is doing things the right way. Of course, the downside is that now you might end up compiling some dependencies more than once. But that's sort of, it has to do that for correctness. But it is a cost that you should be aware of that this might be coming down the pike.
Yeah, I think it's a bit too early to say whether or not it'll actually improve compile times, because it might also in many cases make them worse. But the idea being that hopefully you aren't building your dependencies from scratch very often, so it shouldn't be a recurring cost.
Yeah, I think the idea is that it's going to improve the time for release builds. It's going to fix some of these problems that are just like inherent, right? Like if you're doing a cross compilation at a no-stud, it might be that you just currently cannot build,
Yeah,
and it will
agree that
fix
it's necessary
those.
for correctness.
Yeah. There's another feature that landed in, I guess, Cargo and Rust C. It's sort of an overlapping feature, and this is this notion of splitting debug information on Mac OS. Um, this is a little bit like hairy and weird, but basically, when you do a debug build or any build that has debug symbols enabled, this is the kind of stuff where, like, you run your program, you get a backtrace, or your program crashes, or you try to debug it in GDB, and rather than just getting like pointer addresses for everything, you actually get the names. That's pulled out of the debug information. And how that debug information is stored and compiled varies from platform to platform. And on Mac OS, it used to be that all of the debug information was put into, um, like, it was passed into this tool called dsumutil, which constructed this big folder that contained all of the debug information. And that process was fairly slow, especially if you had like a large binary with lots of debug information and lots of sort of instructions. It just meant there was a lot of debug information. And in particular, it was slow because dsumutil had to be run after linking. So you sort of had to produce your full program binary and then run it and then end up with all this debug information. And that means that even if you make a small change to your program, you might need to like spend a lot of time regenerating all of the debug information. And that's really unfortunate. It means that your builds are slower than they need to be. So what's cool is that in 151, macOS will now take advantage of this sort of different way of storing debug symbols, where rather than extracting them and storing them separately, the debug tool that you use, so this might be GDB, for example, or LLDB, I guess, is another example. It understands how to find the .o files, the like binary intermediate artifacts get produced during compilation. And so you can just leave the debug information in there. And then there are pointers in the final binary that point back to those files. So if you try to debug your final binary, it will just sort of go to those files to find the debug information, which means that if you make a small change to your program, only the files that needed to be recompiled, like the .o files that need to be regenerated, only those have to be regenerated. And there's no longer a need to run this like dsumutil at the end. And this really just should speed up a bunch of compilation cycles on macOS. It is also something I think that is technically possible on other platforms, but just isn't supported yet. Like I
It's
think
on the
on
way, I believe. Yeah. So for Unix, I think for Windows, this has always been the default. I believe, I'm not a Windows developer, but I believe that this is just how debug info has always worked on Windows for all time. And I think that on Unix recently, Dwarf V5 came out and then like standardized how this should be done for Dwarf, the file format. And I think that is being worked on right now. I think LLVM understands it and can do it. I think it just requires Rust to do some more legwork and make sure that it all works.
Yeah, I think you're right. Although I'm not sure about Windows actually. I think Windows uses the same kind
I
of
could be wrong.
structure. I think Windows uses the same kind of structure as Mac OS in that it like puts the debug information in its own separate file, but I think it's like a file and not a folder, and you don't have to run this tool, so it just ends up being a lot more efficient. Like it's really just the whole debug section of the final program binary gets dumped into a separate file, as
Yeah, that's
opposed
what I
to on Mac
expect.
OS where you have to like extract everything into this folder.
Hmm.
Um, so this is like a neat just quality of life improvement for macOS development, I think, which has traditionally been a little bit of a pain with macOS, um, because like it's worked fine, but there's been some of this like we have to call this extra tool and that makes compilation slower and stuff. where this should be this should definitely like improve the experience. I think we can also speak like very briefly to why it took this long to land this on macOS, because it's kind of interesting. So under the hood, the Rust needs to be able to produce things like backtraces, right? So if your program crashes, if there's a panic, for example, it needs to be able to print where the panic happened, and that happens by unwinding the stack. It sort of walks the callers backwards to where the panic happened and sort of prints the name of each one. And traditionally, it used to unwind using a particular library or implementation that didn't support these kinds of new debug format on macOS. It only supported the dsym-util one. But then somewhat recently, there was a re-implementation of this like unwinding component in native Rust. And that native one does support the new format. And so once that landed, we were now able to move the macOS default to be using this new format and still have things like unwinding backtraces work. I think it's just a really cool example of sort of this snowball effect of once this lands, then this can land and this can land, which is similar to what we saw with Const Generics.
That's it for all the tool chain and language changes in the blog post anyway. And then we have new stabilized APIs.
Yeah, so here there are some funny ones too. One is called out in the sort of release announcement itself, which is pointer adder of and pointer adder of mute. So I think we've touched on this briefly, but to recap, in Rust, you're not allowed to create references that are unaligned. Every Rust reference must be aligned, which what exactly alignment means is sort of too technical to get into here, but roughly there are rules for what a reference can and cannot point to. But the same rules don't apply to raw pointers, like a star mute, for example, is allowed to be unaligned. And this comes up in things like if you have a packed struct, so one where there's no padding in the fields to sort of come in the order that you list them exactly as you list them. It might be impossible to generate a reference to any of the fields. And this is a problem because that means it's also impossible to generate a raw pointer to those same fields. Because generally, how you create a raw pointer is you take a reference to the field and then you turn it into a raw pointer. But it's illegal or it's undefined behavior to create an unaligned reference, so you had no way to do it. At least if the struct didn't have repr C, so it was using the Rust representation. And so there's been a lot of discussion of like how do we fix this unsoundness, because it's necessary for things like the offset of macro, which tells you how far into a struct is a given field, because it fundamentally needs to do this operation, but there was no safe way to do it. And what's happened here is that the sort of standard library team aren't willing to commit to any particular mechanism yet. They have some in mind, like I think there's an RFC for this idea of raw references that would solve this problem, but that's still like some way off before it stabilizes. But the need for this particular feature of getting a raw pointer directly from a field is so great that they've landed these two macros, which behind the scenes use this sort of yet to be stabilized feature, but so they've stabilized the macro themselves, but not the implementation, which I thought this is like a really neat example of being able to do this compartmentalization of what you stabilize.
Yeah, so as we've mentioned before, maybe you've inferred, the standard library itself is allowed to use unstable nightly features, and that's because the language and library are pretty closely knit. And so the people behind the language are also behind the library, and so they can guarantee that they won't make any language changes that will break anything in the library, and vice versa, the library won't use or expose any stable APIs that are using nightly features unless those features are like vaguely stable-ish, or at least you can't tell that they're unstable in some way. So, but it's funny because in this case, the reason that these are macros is because they literally expand to nightly only features. And because it's a macro, like you can, you can think of it as kind of just like copying and pasting some code out of the macro into your own code. And then you might think to yourself, okay, so how does this work? If I'm, making my own code and suddenly it just happens to contain some totally unstable code, and I'm not nightly, I'm not using any feature flags, and there's just compiler magic, it turns out, that allows certain macros in the standard library to expand to unstable features and doesn't cause any problems for downstream users. And so if you are using this macro, it doesn't mean that you can suddenly use this unstable raw reference feature that's being prototyped. It does mean that the interface will remain stable forever, but it just means that whatever it expands to will compile on your code, even though it's kind of a cheat.
Yeah, it's a really neat cheat. I didn't know this even existed, but it makes a lot of sense.
It's also a little bit exciting for me, and it's for a tiny reason, which is because I believe this is the well, if you're used to Rust, you'll kind of like maybe understand without really understanding why. All of the macros that you see in Rust, it seems like they're all in the prelude, like panic, printline, format, all these things. You don't need to ever import them, and this is a relic of the time when in Rust 1.0 it was impossible to namespace macros. They just had to always live in the root namespace, and so if you put them inside the library, they're just in everyone's code by default. I believe this is the first macro to be stabilized that is not in the root namespace. It is actually namespaced under the pointer module. And so it does this using some itself kind of unstable support for quote unquote macros 2.0, which has been in the works for quite a while now. And it is stable enough to expose here and use to implement the adder of macros. So I think that's, for me, exciting because I like to have nice looking documentation. And for me, it's kind of gross to have like, here's the front page of the standard library API docs. But also here's your nice, like, list of like all useful modules, and then like a list of like totally random unnamespaced macros that could live somewhere else but don't.
Yeah, I wonder, do you think we're going to see sort of modularization or namespacing of existing macros?
I've honestly thought about writing the RFC for this, where just kind of like, hey, like find places to live for all these macros. Because I mean, it's kind of it's weird in a way where like you would think that you would expect, say, like the vec macro to live like in the vec module, but it doesn't, and so it's kind of unintuitive in that way. And obviously, you can't ever, you can't quote unquote remove them from the prelude. You would need to, if you did this, you would need to implement the macro in a module and then expose it in the prelude so that no code would break.
Well, so there's also the difference here between the prelude and just the source of the standard library, right? So there are macros that are in like stud : vec. That's where vec currently lives, I think, the vec macro. But it would be a matter of like moving it into the vec module. And then still probably, you would still have to expose it under stud because backwards compatibility and whatnot.
Yeah.
Speaking of macros, there's another like macro related change here, which is panic. In particular, there's a new panic any function, which might strike some people as weird. Like, why do we need a panic function when we already have the panic macro? You want to talk a little bit about the difference here? I was really surprised to even learn that there was a difference between like standard panic and core panic and why this was needed.
Well, that's a kind of getting ahead of yourself, but actually, so the idea is that nowadays, or at least I'm not sure if it's stabilized yet, but forthcoming, there won't be a difference between core panic and stud panic. But in the meantime, there is a feature that is in the pipe right now that I'm kind of excited for, and it is implicit formatting arguments for the all the formatting macros. And so, if you've used, for example, pretty much any other language that has what do you call it? It's my mind
like exceptions?
No, not exceptions. No, for in Python, the F strings. What's like the general term for that?
Like formatting strings?
Sure, we'll just call it formatting strings. It's a more general term for it. But like say Python
strings.
That's it. String interpolation. Yeah. And so like any kind of like, JavaScript has this, and like the idea is you can just have a string literal and then just refer to variables in the surrounding scope, and it will pull those into the literal for you and kind of like format it nicely. So in Rust, the way you do it instead is right now you have like say the format macro, which picks a string, format, bang, parenthesis, and then your template, kind of like the string literal with all the curly cues inside. And then after that, you have a list of various identifiers that the macro itself will capture, and then the macro will expand to something that can use these things. And so the idea being that there's nothing actually stopping Rust from referring to, or any kind of like string literal used in this way for a formatting macro, from referring to identifiers in the surrounding scope. And so there was an RFC that was accepted and implemented, and it is now on its way. It's maybe being stabilized probably this year, I would hope. I'm not going to give any promises, but I'm not involved. But the idea being it should kind of bring Rust closer to other languages that you are familiar with string interpolation, where you don't need to list out the name of identifier both inside the string and also outside of it.
That is really exciting.
So that's cool, and that's forthcoming, but there's a problem. And that problem is that, so for this machinery is going to apply to any macro that internally calls the format args macro. And format args is the secret sauce behind all of Rust's formatting stuff that like checks your types are all correct and all this. But there is one exception, just one exception, and that is if the panic macro, if it is called with an argument that is just a string literal, it does not call format args. Every other macro, even if they're just called with a single argument string literal, still calls format args. But because panic doesn't, it means that right now it is legal to invoke the panic macro with just like, imagine like string, curly brace, foo, curly brace, end string. And so with any other macro, that would give you an error because format args is like, hey, you haven't like passed in a foo. I have no idea what foo is. Panic just panics with the string curly brace, foo, curly brace. And that's the only thing that is different between like panic and like every other macro at this point. So the idea is well, like, what do we do about this? Like this one weird kind of like historical exception. How do we fix this? And so the idea, this is kind of the first stage, which is you will provide an alternative where it's, if you are doing this, say, and you like for whatever reason need this to work, you don't want to make any like changes on your own end, this panic any function will do the behavior that you expect. So
maybe it's worth talking about too, like why is it useful to panic with a type that's not a string?
Just for like messages. This isn't like, this is not like, error handling or exceptions. It's just the idea being that well, I guess what you're saying here too is, yeah. So like it'll turn it into a string. So it'll like say, you can, it's kind of like if you want to panic with like, it's for print line debugging, I guess is the idea. But nowadays, a thing that exists that did not exist at 1.0 when this was implemented is the debug macro, the DBG macro, which is way better for print line debugging than panic is.
So what I was thinking of was actually something slightly different, which is if you panic, you can actually supply a value to the panic, and that value gets returned by whoever catches the panic. So if you call panic with a value that's not a string, and then let's say that causes the current thread to start unwinding, right? Imagine some other thread joins with the thread that panicked. The value that was supplied to panic is available to the thread that joins with that panicking thread. So this is when you do join on a thread handle, what you get back is the error type of that is something that you can downcast into the value that was passed into panic. And so this is one way to communicate, like, why did I panic? And it doesn't have to be a string. And that's sort of on purpose, because maybe you want to provide some richer information about why you panicked. And that's available through this mechanism. Okay. And this is why—
I've heard that one before.
Yeah, so this is why panic any doesn't take a string. It takes any type that implements any, send, and static, so that you can downcast into it if you catch the panic. So this could either be through the catch and wind function in the panic module, or it could be because you're joining with a thread that panicked.
Anyway, so the idea is that Go on if you want to continue. I was going to continue, but
yeah. So I was just going to say, like, this is the reason why some people might want to call the panic macro in the past with just a single argument that is a string that they don't want interpolated, or something that isn't a string at all. Like, it's just some other value. And this panic any function is now the way to do that, rather than using the panic macro, which is going to start formatting.
yeah, I'd say it's still pretty rare. Nothing that you really want to do very often.
Oh yeah,
but it
no,
is
not
possible.
at all.
Yeah. Anyway, so the idea being that with the addition, this discrepancy will be papered over and like fixed, quote unquote. So Panic will begin to participate in the machinery of getting the implicit arguments. And this is just kind of like adding in the ability for people to migrate as well, in addition to what you said.
Yeah, I think this is really nice. It's sort of separating out that the panic macro will be for the same things like the print macro for, except you're also panicking.
Mm-hmm.
And then if you specifically want the feature where you're able to like propagate a panic value, then you use the panic any function rather than go through the macro. I think that's like correct cleanup. It's great. I think there are two other things I wanted to talk about from the stabilized APIs. The first of them is pretty straightforward. So it's a bunch of methods that have been added to Slice. This is stuff like split inclusive, strip prefix, and strip suffix. And these are, at least in my mind, ways of making slices feel more like strings, or rather give more of the conveniences that you currently have with strings. So to take strip prefix as an example, what strip prefix does is on a string, that is, you can, if you have a string that says foobar and you call dot strip prefix and you pass in the prefix foo, the string prefix foo, it'll return sum of bar. So it'll slice the string for you to not include the prefix you gave. And if the prefix isn't there, it returns none. So this is a really handy way to strip a prefix from a string if it's there, and to learn whether or not it's there in the process. And previously, if you had something like a byte array or something, and you wanted to strip if it started with a given byte sequence, like for example, if you're dealing with ASCII text and you have like a U8 slice, and you want to see whether it starts with this U8 slice, previously that was actually really annoying to do. And it's nice to see slices get some of these like just quality of life improvements that we've had for strings for a long time, and really could just have for slices too. I think we're going to see more of these land in like the coming releases, and I'm pretty excited about it. The other one is task wake. So we're not going to get into all the details of like how async await works and stuff, but a waker in async await is a way for a future to say that, or for something to say, this future is now ready to make progress. Like it returned pending in the past, it was like waiting, and now wake it up, try to pull it again, try to make progress. And previously, if you wanted to like write your own little executor or something, creating a waker to pass into polling a future was really, really annoying. You had to deal with like manually constructing like a V table from raw pointers. It was really hairy, and for good reason. It's because it should be low overhead. But if you just wanted something to like get up and running, and you didn't really, the overhead wasn't that important to you, like you were mocking an executor or something, it was a huge pain. And now what's landed is the wake trait. And the wake trait is a sort of a helper trait. And this might be the first of these I've seen in the standard library, where what trait does is you implement the wake trait for arc of your type. So you implement it for your trait, for your type, your waker type, but all of the methods receive an arc to self. And then you implement these sort of methods that are required for wakers that way. And then the wake trait takes care of implementing waker so that you can now pass that into the context that's needed for a future. It's a little bit convoluted, but basically the wake trait makes it so that normal human beings can implement wakers themselves, and that way can implement executors themselves without too much like of this additional raw, unsafe business with vtables that you had to do in the past.
One extremely minor API I wanted to kind of call out here are the peekable next if functions that were now stabilized, and not for the functions themselves necessarily, but because just for the peekable combinator on iterators, which allows you to take an iterator and then make it so that you can see the next element of the iterator without advancing the iterator. So it's a very kind of like nice, convenient thing that I think needs more press.
Oh yeah, peekable is fantastic. I use that a lot.
Yeah.
Yeah. And in fact, I think the easiest way to get a peekable is if you have any iterator, you can just call peekable on it, and that gives you a peekable iterator.
Yeah, it's great.
And then I did my deep dive into the other changes. Here too, I think there are two that I want to call out. The first one is a really nice quality of life improvement for Rustdoc, where now it'll show you the documentation for methods that you get through deref, even if you go multiple levels deep. So the example from the PR is, imagine you have some type foo that implements deref to pathbuff. Or let's use string instead. String might be a better example. So foo implements deref to string, and string, of course, implements deref to stir. And previously, if you rendered the documentation for foo, you would only get the methods from deref string, not the ones from strings deref to stir. But now you will get the methods sort of inherited through deref all the way down. So it would include both string and stir. Or if you had something that derefs to pathbuff, it would include both the methods from pathbuff and the methods from path, which pathbuff implements deref to path. So that's nice. It just means that our documentation is going to be more complete. Like, it'll actually show off all the things that you can call without you having to like click your way through a large hierarchy of types. The other one is much lower level, and that is, there's this configuration option you can set for rustc called target CPU, which is basically which CPU should you compile this code for. And that dictates things like which optimizations are enabled, but also which instructions are enabled. So different processors often have different sort of instructions that do particular things in a more optimized fashion. And there's a value you can pass for target CPU, which is target CPU equals native, which is basically figure out what CPU I have and then compile the fastest code you can for my CPU. And this is something that can often lead to pretty significant improvements in runtime. But it had this unfortunate, I guess, bug, or it was very naive in that if you gave target CPU equals native, it used to be that it just sort of figured out the name of your processor and then enabled the features that a processor by that name should have. And this has two failure modes. One is if your processor happens to not implement a feature that's implied by its name, then now you're going to get a binary that you can't run because it's using instructions your CPU doesn't support. There's also the other way around, where if your CPU reports to be a processor of a given name or a given family, and that family of processors don't usually support a given instruction, but your processor does, then you would lose out on that optimization on the use of that instruction. And so now what's landed is if you specify target CPU equals native, it will actually detect all of the different features rather than going by processor family. And so now you should only get the features that your processor supports. And that might mean that you now get more features like faster code, more widely used or wider use of instructions. And it also means fewer miscompilations. So this is just like a nice thing for those who want to squeeze every last little droplet of performance out of their programs.
It reminds me kind of websites that used to test the user agent. That's kind of like the old
exactly
behavior,
like
and now it's about testing which APIs you support, which is the nice way of doing things.
Yeah, it's a really it's really the right way to do things, is I think the way to think about it. I think at the tail end here, I didn't have anything more about 151, but there's been another. We sort of like on this podcast, I think, to call out larger ecosystem efforts that you might want to get involved with. And one of these that you mentioned, Ben, was the async Rust shared vision document or working group. You want to talk a little bit about this?
Sure. So, async Rust, obviously, just like how Const Generics became an MVP this release, async support in Rust is still kind of an MVP. There are a lot of future improvements that are kind of needed to make it more ergonomic, more useful, more capable. And a lot of the planning for this has been kind of stalled on like getting user feedback. And so the people working on async right now are requesting feedback from people saying, hey, like, how do you use async? How do you like, how is it currently and what would you expect it to be like? And they kind of want to create this vision document to figure out, okay, where should we go? What should we pursue next? What are our goals? Where should Rust async be in like 5 years? So we will link to this as a great blog post by Nico Matsakis. And you can participate. You can, I think he's been doing weekly meetings with folks, kind of trying to like in the community just to like be like, hey, like what is your like need? What do you envision? So if you use async Rust, feel free to chip in, give your experience and what you think Rust should go towards.
Yeah, and I've been watching, they've set up like a repository for this where you can sort of submit issues and PRs with your story, if you will. And one thing that I think is worth calling out is that it can be really simple. It's not, you're not expected to propose like a solution. You're not expected to know everything about the problem or anything like that. It's really just, if you've ever tried something with async and it didn't work or something was a pain, then tell us about it so that we know about this use case and know to sort of optimize for it, know that it's a real one. And it can really just be about writing a short story about some experience you had with async in Rust. I think the phrase from the blog post is, our goal is to engage the entire community in a collective act of the imagination, which I think is a very nice way to phrase it.
Mm-hmm.
I think that's everything. I think we got through two more releases, Ben.
Yeah, we're getting older.
Yeah,
as Rust gets older, so do we.
Yeah, I hope we don't age with the Rust version numbers. That would be unfortunate. I think as a last call to action, remember that Rustacean Station is a community podcast. So if you have anything you want to see an episode on, if there's a technical contribution or a project or a feature request, or just a person you want to talk to, like someone you want to interview, anything like that, then please reach out to us. We have a Discord where you can reach both Ben and me and a bunch of people in the community. And we'll help you get started, get set up, and record an episode and get it out there. It gets better the more people sort of put things that they are interested in out there, and we're happy to help.
Yeah.
And with that, I guess we will now shut down, Ben, and restart our cron jobs, and then we will turn back on again in 12 weeks.
3 months.
Nice.
All right.
See you then, Ben.
See you around, folks.
Bye.
Bye.